take a quick look at the antiderivative, which is basically our integration. Some of the integration formulas that were covered in Calculus 1. The integral of 0 with respect to x is equal to just c. What that means is the derivative of a constant c is equal to 0. Alright, so all we're doing, it's like taking the derivative of c and working backwards. Alright, the integral of some number, let's say some number k, with respect to x, is equal to that number k times the integral of 1 dx, or you can say just k times x plus c. Alright, so for example, if this was the integral of 3, you could say that's the same thing as 3 times the integral of 1 dx, or 3x plus c. All integrals, or all indefinite integrals, will have plus c on the end. If it's a definite integral, which we'll eventually go over, we don't put plus c. But all indefinite integrals have plus c. That means plus, that's the constant of integration. You say, why is there a plus c? Well, if I took the derivative of this, then that would give me k, and then the derivative of the plus c is 0. So I'd just be left with k. So that's why we always put plus c on the end of our integrals. Alright, if you take the integral of multiple terms, you may have one function plus or minus some other function, and the functions can be anything. That could be an x and an x squared, that could be a 2 minus x, whatever. They can be simple functions or they can be complicated functions. With respect to x, then what you do is you simply integrate each function separately. So that's the integral of f of x plus or minus the integral of g of x. And that is both with respect to x. So you make sure you want to put the dx on here. The dx is our differential. And that tells us what we're going to integrate with respect to. Okay. Now, I guess the biggest rule that's covered whenever you go over the antiderivative in this section, or the first section in this chapter, is the power rule. Let's see me get mad.